So the sum and difference formulas are when you're going to have like the sine of two angles added to each other, or the tangent of two angles subtracted from each other. And so we can use those formulas to find the sine of an angle that isn't a special angle. So an angle that you can't do the hand trick to figure it out, we can use these formulas to figure it out. So a lot of times, if you're given one that's in radians, like all of the ones we're doing today, you're given a hint. So you're finding two special angles that either add or subtract to give you 12 or 7 pi over 12. And so it's nice that they went ahead and told you if you add pi over 3, pi over 4, you get 7 pi over 12. And somebody in my last class was like, how do you get the 7? It's just finding a common denominator and adding them together. So I promise you, if you add those two, you get 7 pi over 12. So what we would do first is just rewrite 7 pi over 12 as pi over 3 plus pi over 4. All right, and then you're going to look at your identity sheet and decide which identity we're going to use to figure this out. So which one does it look like? Which number? 24, the first one, right? So the sine of two angles added. So what we would do is we would say that this is u, the pi over 3, and that v is pi over 4. And then we're just going to use that identity, and where u is, we're going to write pi over 3, and where v is, we're going to write pi over 4. So let's just sub it in, the angles for our problem into the identity. All right, and then what do you guys think we do now? Can you find the sine of pi over 3? We don't need another identity. We can figure this out from here. If you guys were going to do the hand trick, which finger do you use for pi over 3? Pointer finger. And then for sine, do we do square root of the bottom or square root of the top over 2? Square root of the bottom. So that's going to be square root of 3 over 2. All right. And then pi over 4 is another special angle. We can use the hand trick. We're going to use the middle finger. And we do the square root of the top fingers over 2. All right, so you guys find those two for me, please. Cosine of pi over 3 and the sine of pi over 4. And then from here, it's just multiplying fractions, adding fractions. It's not really trigonometry at this point. It's just combining all these fractions together. So we'll start by multiplying. So if you multiply the square root of 3 by the square root of 2, what do you get? Square root of 6. So if they're both under the square root, you can multiply them together. And then 2 times 2 is 4. Right, and then 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. Right, and then we would write this as one fraction with the common denominator as the denominator. And can we add the square root of 6 and the square root of 2? No. To add radicals, they have to be like radicals. These are not like radicals, so this is it. This is our answer. So that is the exact value of the sine of 7 pi over 12. All All right, let's look at another one. So this one, we're going to find the cosine of 13 pi over 12. We're given a hint that tells us how we can use special angles to get 13 pi over 12, subtracting those two. So the first thing I would do is rewrite it. So instead of writing 13 pi over 12, I'm going to write that as 5 pi over 4 plus u minus pi over 6. All right, then we're going to look at our identity sheet. Which one does this one look like? Yes. So number 27, cosine of two angles that are subtracted. So we're going to have u be 5 pi over 4, and v be pi over 6. So we would just use the formula to write it out. All right, now 5 pi over 4 is not one of our fingers, but we can use the pi over 4 finger to find the sine and cosine of it. But we need to know what quadrant 5 pi over 4 is in, because it could be positive or negative. So what quadrant is 5 pi over 4 in? 3. Okay, so down here, when I go to find all these, is cosine positive or negative in quadrant 3? Negative. So I just put a negative in that parenthesis, and then I don't have to worry anymore with it. And then what about sine in quadrant 3? Also negative. Okay. All right, and then from there, I can just use the pi over 4 finger to find the cosine of 5 pi over 4. Right, and use the pi over 6 finger to find the cosine of pi over 6. All right, you guys do the other two on your own, please. And then just like the last problem, we'll go ahead and multiply our fractions together. And then add. And that's the exact value of the cosine of 13 pi over 12. Now you're going to notice very, very similar answers over and over again, because there's only so many things you get from special angles. There's only so many fractions you end up with. So you'll see kind of the same things over and over again. All right, so we're going to do one more, and then we'll talk about some things that are a little different. Now, on most of these formulas, if you guys got them all filled in, the tangent formulas seem to be just a little more difficult than all the others, than the sine and cosine. So this one is going to take up some space, and I didn't give you a whole lot, so you might want to write over in the margin and write kind of small, because it is going to take up a lot. All right, so they give us our hint that we are going to, for 5 pi over 12, we're going to use pi over 4 plus pi over 6. So that's where I'm going to start. So I'll have my u be pi over 4 and my v be pi over 6. All right, so we're looking at the tangent of two angles added to each other. So you all figure out which formula to use, and then go ahead and fill in your u and your v, please. If you don't have the formulas filled in, you can grab a book. You're going to need them. At least you're going to need these for today, the 6. Alright, should be 375. Alright, then you get a book. It's page 375. If you don't have these identities on your desk, this lesson makes absolutely no sense. Okay, so this is what you should get when you plug in your u and your v. All right, so we're ready to go ahead and find the tangent of pi over 4. What do y'all think? Right, so it's basically the square root of 2 over the square root of 2, which is 1. Good. All right, and then what about the tangent of pi over 6? Well, it's 1 over the square root of 3 or the square root of 3 over 3. Is that what you said? No? Okay. Yeah, make sure you do bottom over top. Okay, and then in the denominator, we are using those same values, but instead we're multiplying them by each other. All right, and then I'm gonna just clean this up a little bit by multiplying by 1. All right, we have 2 things that are wrong with this. What's one of them? Fraction inside of a fraction. That's what we're gonna take care of first. Now the way these problems work out for you to be able to use special angles is you end up with, if you have a situation like this, these are typically the same denominator. They're both 3. So we don't want a fraction and a fraction. So what can we multiply by to get rid of the little denominators? What can I multiply the square root of 3 over 3 by so I don't have a fraction anymore? Just 3, yeah. And it's legal, it's perfectly legal on a fraction to multiply the numerator and denominator by the same value. It doesn't change anything. It changes the way it looks, doesn't change the value. All right, and then make sure you do distribute those 3's. Okay, so what's the problem now? Radical in the denominator. Now this one's a little more difficult than whenever we had 1 over the square root of 3. We did that in a second. It was no big deal. Because of that subtraction, we can't just move it up and change it to regular 3. We have to do something else. Do you guys remember what we do? Yes, nice job. We're going to multiply by the conjugate of the denominator. So it's 3 minus the square root of 3. So we're going to multiply by 3 plus the square root of 3. I know you guys are probably running out of room. We have a couple more things to write. All right, so in the numerator, we have to do all the distributing. So we have to distribute the 3. And then we have to distribute the square root of 3. However, in the denominator, because they're conjugates, we can do a shortcut form of that, where we just multiply the 3 times the 3, and negative square root of 3 times square root of 3. All right, so y'all go ahead in the numerator and denominator and combine your like terms, please. All right, and then what can we reduce everything by? Actually, we can reduce everything by 6. Now, the square root of 3 is not really 3. It's some ugly decimal. It stays the square root of 3. You can't reduce it. But everything outside of the radical can be reduced by 6. And so we're just left with 2 plus the square root of 3. That is what the tangent of 5 pi over 12 equals. So there's a lot of steps. Now, sometimes these work out where you don't have this particular step. So just depending on what angle you have, sometimes you don't have a fraction in a fraction, but we're always going to have that radical. Okay. Now, sometimes this box is really important. Sometimes you'll have like a problem in disguise. Like when you see both of these, it looks like you're going to use that formula where it's the sine of 2 angles subtracted. And one of them you would, and the other one is easier to do another way. All right, so when you see these, what I would do is, when they're written this way, is look at the angles and ask yourself, are these special? So the special angles are the angles you can do from the hand trick. So what are the denominators of special angles? 2, 3, 4, and 6. So if your denominator is one of those numbers, then it is special. So these are special, so we would say yes. And then if they are special, then you use the sum and difference formulas. Because the angles that you use for your u and v in those formulas have to be special. If they're not, you're not going to be able to figure it out. Okay, so same thing on the other one. You look at these angles that you're subtracting. You ask yourself, are these special? What do y'all think? No. If it's reduced, and those are both reduced, and the denominator's 12, it is not special. So then you're going to go ahead and subtract. So that's going to be sine. What do you get when you subtract those? Yeah, originally we get 4 pi over 12, and then like he said, that's just pi over 3. Can we find the sine of pi over 3? Super fast. We just use our pi over 3 finger. This is the square root of the bottom fingers over 2. That's so fast, so much faster than the ones we just did. But the problem is, it's written in a way to trick you, so don't let it. So before you plug in values, plug in your u and v, double check that they're special angles. If they're not special, it's not going to work. And you can do it in like a quarter of the time. All right, so let's look at example 2. This looks like we would use that one we just did for tangent. But we're not going to, because these are not special. The denominator of 16 is not special. All right, so what we'll do is go ahead and add these. So we add 7 pi over 16 and 5 pi over 16. Just the first step is 12 pi over 16. And then what does that reduce to? Good. 3 pi over 4 is special. We can find the tangent of 3 pi over 4 super quickly. First, what quadrant is it in? Second. Is tangent going to be positive or negative? Negative. We use our pi over 4 finger. What is the tangent of 3 pi over 4? Which is 1, so negative 1. Be careful. I did throw one of those on your problems. At least one. Yeah, just one. All right, are y'all okay? Okay, the rest of this assignment I think is a little easier than those that we just did. So what we have on example 3 is the formula has already been applied. And what we have to do is go backwards to the original problem. So looking at what you wrote in your blanks yesterday, we have sine cosine minus cosine sine. Which one does that look like? Yeah, you're right. So the sine of u minus v. So what do you guys think u is? 3. And then v should be 1.2. So this is really, originally, the sine of 1.8. Now, can we figure that out without a calculator? No. 1.8 is not special. We can't figure out the sine of 1.8 without a calculator, so let's just leave it. We just leave it like that. All right, y'all try B on your own. All right, so this one looks like the tangent of u minus v, which I'll get for u, 45 degrees, is 30 degrees. Now, is 15 special? It isn't. Well, we're going to talk about the special angles and degrees more tomorrow, but the degrees are 30, 60, 30, 45, 60, and 90, and then the multiples of those. So we're done. That's all we do. Okay, and then this last one, we are going to do what we just did, but then it is going to be something we can figure out. All right, so we have cosine, cosine minus sine, sine. What does that look like? Yeah, so it's the cosine of u plus v. So u is going to be pi over 16. V is going to be 3 pi over 16. We would go ahead and add those together. And I'm showing every little step. So if you add those and reduce it all in one step, that's great. Don't worry. But it's going to reduce down to the cosine of pi over 4, which is a special angle. We can find the cosine by doing the square root of the top fingers over 2. Do you guys have any questions? All right, your assignment is down here. Be really careful on 1, 2, and 3. You're going to need to ask yourself if they're special before you start